Okay. So what we're going to do here is we're going to solve systems of linear equations by graphing, substitution, and addition or elimination. Addition and elimination are the exact same process. So what we're going to do here is we're going to take just one common system of equations and we're going to solve it by graphing it. We're going to solve it by using substitution, and then we're going to solve by using addition or elimination. Again, addition and elimination are the exact same things. So this handout can be found on Blackboard. It is a good idea to print it out and to do these yourself. So these are just extra problems to show you how it works. And on your exam, you're probably going to be asked to take a system of equations and you're going to have to show how you would solve it by graphing, how you would solve it by substitution, and how you would solve it by addition or elimination. You will have to show all three of these things. All right. So the first thing that we're going to do here is we're going to solve this system of equations by graphing. Now to do that, there's a few different ways. So you can either take these two equations and you can make an XY table for both equations, come up for points and label those points. The other thing you can do is put these in slope-intercept form, which just means you solve for y. You'll be able to find the slope and you'll also be able to find the y-intercept. So the first problem here, I think I'm going to solve this by using the slope-intercept form. So what we're going to want to do is take both equations, write them out separately, and what we're going to do is just solve each for y. And when we do that, we'll have that in the form y equals mx plus b, where m will be our slope, the coefficient out in front of x, and b will just be the y in the xy coordinate for the y-intercept. So to get y by itself here, we can subtract x by both sides of the equation, and we'll end up with y is equal to negative x plus 1. So here is this equation in slope-intercept form. We will know what the slope is. The slope, is just the coefficient out in front of x, which is a negative, so it's a negative 1. And then the y-intercept will be a point in the form 0, and then whatever this value is on the end. Here it's positive 1, so that will be a positive 1. We know what the slope is, and we also know what the y-intercept is. We can do the same thing here, solve for y. We'll subtract 2x from both sides of the equation. We'll have negative y is equal to negative 2x plus 5. Now here we have a negative y. We need that to be a positive y. So all we have to do is either multiply or divide each side by negative 1. So when we do that, negative y divided by negative 1 becomes a positive y. So here we have negative 2x divided by negative 1. This becomes a negative divided by a negative is a positive. So we'll have 2x. And then positive 5 divided by negative 1 is a negative 5. So now we have this equation in our slope-intercept form. Our slope is just going to be the coefficient out in front of x. So that's going to be 2. And then our y-intercept is going to be in the form 0, and then here we have a negative 5, which means this value in our y position will be negative 5. So now what we can do is we can work with this one. Our y-intercept is at 0, 1. So at 0, 1, this is 1 point on our line. Now to find a second point, we're going to take a look at what our slope is. Remember, we have negative 1. Every whole number can be a fraction divided by 1. And remember, this is rise over run. So this means when we go down 1, negative means we go down in the rise position, we will go right 1. So from our point that we found, if we go down 1 and right 1, we have a second point on our line. And all we need are 2 points for a line. And you could have done it the other way as well. Instead of this being a negative 1 on top, you could have put the negative on the bottom, which just means every time you would have went up 1, you would have went left 1 as well. So if you did that, you'd be here, you'd go up 1 and move left 1. It doesn't matter which direction because as you can see, it's going to be on the line. And then what you could do here, and if I can do this, it's kind of a weird angle, but you draw this line. And this line would represent our first line. And what I'm going to do is label this 1, label this 2, and this is the line for, this is the graph for the first equation. So we can do the same thing for the second equation. Here we have our y-intercept at 0, -5. So that means when it's 0, -5, and in fact what I'm going to do instead is use a red so we have a little bit of a difference here. So we have a slope of m2. So let's take a look at that as well. When we have 2, every whole number can be a fraction over 1. Rise over run, which means for every 2 we go up, we will go right 1. So from this point, we will go up 2, we will go right 1. So from here, we now have another value. All you need is 2 points. And what we can do now is just draw this line. So graphing is going to be a little bit tricky because, as you can see, where it intersects is not exactly on the line. But the point is, right here at this spot, which would end up being 2, -1, that point of intersection would be the answer to our system of equations. So here we have 2, -1. Now, does this make sense? Well, we can easily check. Remember that all ordered pairs are x, y, so all you have to do is just take either one of these equations, it does not matter which one, and then substitute our values that we found. Let's take this first equation here. X plus y equals 1. Well, when x is 2 and y is -1 plus a -1, we get 1. Does that make sense? 2 plus a -1 is in fact 1. 1 does equal 1. That is a true statement. That means our answer must be correct. So our answer here by graphing, and what I did was put this in slope-intercept form. You could use an XY table. There's a few other things you could have done, but you'll still come up with the same answer regardless, 2, -1. All right, so now what do we do if we're going to solve by substitution? So to solve by substitution, what you need to do is either solve for this x or this y in this equation, or solve for this x or this y in the second equation. It does not matter which one you solve for. Point is, you just need either x by itself to equal something or y by itself to equal something. So just to stick with our standard tradition, I'm going to take our first equation here, and we're going to solve this for y. Just because that'll put us in our slope-intercept form, it makes life a little bit easier. So to solve for y here, I'll come over to the side. X plus y equals 1. All we have to do is subtract x from both sides of our equation. And what we end up with is y is equal to -x plus 1. So this is our first equation, just written in a different way. Now we see that y is equal to this whole quantity, -x plus 1. What we'll do is take this y and we'll substitute it into our second equation. So when we do that, this y will be -x plus 1, and that whole thing will be subbed in for y. So when we do that, we'll have 2x minus y, which is now -x plus 1, is equal to 5. So now what we need to do here is just solve for x. Well, we have a negative times a quantity. We have to distribute this negative across both terms. So when we do that, we get 2x. A -1 times a -x becomes a positive x. A -1 times a positive 1 becomes a -1. That still equals 5. Here we have like terms. So now we're going to combine these two like terms. 2x plus x gives us 3x. Minus 1 equals 5. We can add 1 to both sides of our equation. When we do that, we end up with 3x is equal to 6. Now we can solve for x by dividing both sides by 3. And what we have is x is equal to 2. This is a good sign because we expect to get the same exact answer that we had up here. Up here we found x to be 2. Here we found x to be 2 as well. So we know we're on the right track. Now the last thing we need to do is just solve for y. Now when x equals 2, all we have to do is substitute this either back into the original equation or any equation we have altered. Here we already have y equal to something. So what I'm going to do is simply just substitute our answer of x equals 2, and we're going to put 2 in for x. So y is equal to -2 plus 1. Well, -2 plus 1 is a -1. So we have y is equal to -1, which is exactly what we found in our first problem. So that's a good sign as well. So remember, our solution is a point. So when we give our answer, we want to put our answer in the form of an ordered pair, So x is 2, y is -1. So as you can see, just like what we had up above, it's the same answer, which is exactly what you would expect. All right, so the last thing we can do is solve by addition elimination. Remember, addition, elimination, they're the same thing here. So in order to do that, we need to have one of two things happen. Either the coefficients in front of the x have to be the same number but opposite sign, or the same thing for y. It needs to be the same coefficient but the opposite sign. So here we're lucky in the sense that we already have that. The coefficient out in front of y is a +1. Remember, it's always implied that there is a 1 out in front. And the same thing with the -y. It's implied it's a -1 out in front. So the coefficient is the same number with opposite signs. When you have that, all you need to do now is simply just add them together. So when we add these two equations together, what we'll have is x plus 2x equals 3x. Y minus y is 0. And that's exactly what we're looking for. We want to eliminate one of the variables. So now we have 1 plus 5 equals 6. We have the equation 3x is equal to 6. So we can solve for x by dividing 3 on both sides, and we get that x is equal to 2. Again, the same thing we found here, the same thing we found here. So we know this is a good sign. Now that we know one value, all we have to do is take x and substitute this back into either one of these equations. It does not matter which we used. So last time we used this equation here to solve. Now I'm going to put it into the second one. Remember, you can put it into either or. I'm going to put x equals 2 into this equation. So we have 2x minus y equals 5. I'm going to take 2 and substitute that in. 2 times 2 minus y equals 5. 4 minus y equals 5. We can subtract 4 from both sides of our equation. We get that the opposite of y is equal to 1. The last thing we have to do is get this to be a positive y. To do that, we multiply or divide both sides by -1. And when we have that, what we have is y is equal to -1, which is exactly what we found here, which is exactly what we found here. Remember, our answers are always as ordered pairs. So here it is 2, -1, where a x goes first, then the y. So as you can see, these are three different ways to solve systems of equations. We graphed it, we did it by substitution, and we also did it by addition and elimination. All right, so now let's look at another problem. This is the one thing I didn't practice. I simply tape the paper so it stays in frame, and as you can see, it's kind of a problem. All right, so now let's look at another system of equations. We're going to do the same thing. We're going to solve by graphing, we're going to solve by substitution, and we're going to solve by addition and elimination. So the first thing we want to do to solve graph is you can either put this into slope-intercept form. This time, I'm going to use an XY table. So last time we just put it in the slope-intercept form. This time, what I'm going to do is I'm going to write out both equations. 2x plus 3y is equal to -3, and x minus 2 is equal to -5y. And what I'm going to do is create an XY table. In other words, we're going to put in values for x, and then we're going to solve for y. All right, so in this first equation, I can see, and this is just something from experience, that we have a 3 multiplied by a y. That's going to mess up our numbers a little bit, and we're going to get fractions unless we use the right numbers. So what I'm going to do is use the numbers -3, 0, and 3. I'm just simply going to use numbers that is out in front of the coefficient of y. The reason I'm doing this is we will eliminate fractions. You could still put in 1, you could still put in other numbers, but then you're going to end up with a fraction. It's not going to change your answer, it's just going to make things a little more complicated. So when x is negative 3, we simply just substitute negative 3 in for here. 2 times negative 3 would be negative 6 plus 3y. In fact, what I'm going to do is just do the whole thing anyway. So when x is negative 3, we're going to have 2 times negative 3 plus 3y is equal to negative 3. Negative 6 plus 3y is equal to negative 3. We can add 6 to both sides of our equation. We have 3y is equal to 3. Divide both sides by 3, not y, and we get that y is equal to 1. So when x is negative 3, y is equal to 1. Now we can do the same thing for 0. 0 will be a lot easier. 2 times 0, well, anything times 0 is just 0. We have 3y is equal to negative 3. We can divide both sides by just 3. So we have y is equal to negative 3 divided by 3, which is a negative 1. So already we have 2 points. That's enough to draw a line, but it's always a good idea to just put in a third point just to make sure these 2 points weren't off by a little bit. So when we put in 3, we'll have 2 times 3 is 6. And again, I think I'm going to do this just down here. When we have 3, we'll have 2 times 3 plus 3y is equal to negative 3. 2 times 3 is 6 plus 3y is equal to negative 3. We can subtract 6 from both sides of our equation. When we do that, we'll have 3y is equal to negative 9. We can divide both sides by 3, and we have that y is equal to negative 3. So when x is 3, y is negative 3. And this should make sense. We are increasing by the same amount. We have gone a distance of 3 units. Remember, distance is always positive. So that means our answers should be going the same way. Here it's a distance of 2. Here it's a distance of 2 again. So this does make sense. These are your ordered pairs. You have negative 3, 1. You'll have 0, negative 1. And you'll have 3, negative 3. So what we can do is literally plot these. So at negative 3, 1, we'll have 1 point. 0, negative 1. And then 3, negative 3. So when we do that, we end up with 3 dots, and this will form a line. And again, I'm just trying to do my best here. It's a weirder angle, but we'll have this line right here. I'm going to label this 1 and 2. This is line number 1. So now we'll do the same thing over here as well. So what we can see again is that we have kind of a weird number. We have a negative 5y, and I'm going to pick strategic numbers again. I'm going to pick negative 3 only because negative 3 minus 2 is a minus 5. Then we'll end up with something easy. I'm going to pick 2 because 2 minus 2 is 0, and anything divided, or 0 divided by anything, will still be 0. And then the last number I'm going to choose is 7. I went a distance of 5 between these two. I went a distance of 5 again. The reason I'm doing that is 7 minus 2 will give us 5, and we'll have a much easier time doing this. So when we put in negative 3 minus 2 is a negative 5. Negative 5 equals negative 5y. We could divide by negative 5, and we'll end up with a positive 1. So when we put x equals 2, 2 minus 2 is 0. Negative 5y equals 0. If we divide 0 by negative 5, it's still 0. Remember, we can always do 0 divided by anything that's not 0. We just cannot divide anything by 0. 0 cannot be in the denominator. It cannot be on the bottom. And then the last one, we have 2 points. We could draw this line, but it's always a good idea to check. 7 minus 2 is positive 5. 5 divided by negative 5 is negative 1. So here you can see we stepped a distance of 5 units. Here the answer moves a unit of 1. They're all uniform, so that's a good sign. So when we do this, now we have ordered points. Negative 3, 1, 2, 0, and 7, negative 1. Well, lucky for us, we can already see we have 2 points that are the same. That means that will be our answer. But we still want to plot these points. So negative 3, 1 will be the exact first point that we had before. 2, 0 which means when x is 2, y is 0, and then 7, -1. When x is 7, we have -1. So what we can do here is draw another line. Try and draw this pretty well. And what we can see is that we do have an intersecting point. And specifically, it is at the point 1, 2, -3, +1. So our answer here is -3, 1. Remember, it's always x, y. Well, does this make sense? Well, we can take these values and put them back into one of the equations. It does not matter which one. 2 is clearly going to be the easier equation because we don't have a coefficient out in front of x. So let's try that. X minus 2 equals -5y. We'll substitute -3 in for x, and we'll substitute 1 in for y. So we'll have -3 minus 2 is equal to -5 times 1. Well, -3 minus -2 is a -5, and -5 times 1 is a -5. This is a true statement, so we know that our answer, -3, 1, is correct. All right, now let's solve this by substitution. So to do substitution, remember, you either solve for this x and get it by itself, you solve for that y and get it by itself, you solve for that x and get it by itself, or solve for y and get it by itself. Well, clearly it is going to be very easy to solve for x because x is already by itself. So we're going to take this equation. I'm going to add 2 to both sides of my equation, and I'm going to end up with x is equal to -5y plus 2. So now what this means is that x is this quantity in terms of y. So what we're going to do is take this x, and we're going to substitute it in for that x in our first problem. So we're going to have 2 times x, which is now -5y plus 2. It's the whole thing. Plus 3y is equal to -3. So here we have a number multiplied by a quantity. We're going to have to distribute across. So 2 times -5y is -10y. 2 times +2 is 4. Plus 3y is equal to -3. Well, we have like terms. We have -10y plus 3y. That's going to give us a -7y. Plus 4 is equal to -3. Now we can subtract 3 from both sides of, 4 from both sides of our equation. And we'll end up with -7y is equal to -7. And now to get y by itself, we simply divide by -7. And what we have is that y is equal to +1. -7 divided by -7 is a +1. This is a good sign because remember, our answer up here, we found y to be 1. So we expect to have the same value. These are the exact same set of equations. So now that we have y is equal to 1, all we have to do is substitute y back into either one of the equations and solve for x. Here I'm going to sub it back into the second equation. So x minus 2 is equal to -5y. And again, you can use either one. You do not have to use this one. I'm going to substitute what we found, y equals 1, in for y. X minus 2 is equal to -5 times 1. X minus 2 is equal to -5. To get x by itself, we simply can just add 2 to both sides of our equation. When we do that, we get x is equal to -3. This is a good thing because this is what we found in our first one. X was -3. It's this spot that they intersect. So we have an x and we have a y. Remember that all answers are in ordered pairs. So it'll be -3, 1. And here is our answer. It is the exact same answer we got up here, which is what you want. All right, so now the next thing we want to do is solve by addition elimination. So once again, we need the coefficient out in front of either the x's or the y's to be the same number of opposite signs. So here we don't have that. And in fact, our y is sitting in the wrong spot. What we are going to have to do is put this back into standard form, which means it's going to be in the form ax plus by is equal to c. In other words, we need to move this y over to this side to join the x, and then we need to take this value of -2 and put it over here to be the coefficient. So that's what I'm going to do. I'm going to add 2 to both sides of my equation. I will get x is equal to negative 5y plus 2. And then to get x and y on the same side, because that's what we need, I'm going to add 5y to both sides of my equation. And what I'm going to have is x plus 5y is equal to 2. So now this is in the correct form, and we have two different ones. We have our first one, and we have our second. And notice I'm drawing the second one in the correct form. So now what I'm going to do is simply just place these over each other. I will have 2x plus 3y is equal to negative 3. And now our new equation, x plus 5y is equal to 2. Now what we still need is the same value but opposite signs for either x or y. Now if you wanted to do y, what you could do is multiply this bottom row, this entire thing, by 3. That would give us 15y. And our top row, we can multiply the entire thing by 5. Negative 5, excuse me. That would give us negative 15y. We'd have negative 15y plus 15y. These would cancel and you could solve. However, it's going to be much easier just to deal with the x's this time. Remember, we need the same value out in front, so it needs to be a 2, but it needs to be opposite signs. So what I'm going to do is multiply my bottom row, the entirety, by negative 2. That means it has to distribute across all 3 terms. Now, when I do that, I'm going to get, and I'm writing the first equation again, 2x plus 3y is equal to negative 3. This is just this equation. I'm not changing anything. Here we have negative 2 times x. We'll have negative 2x. This is what we want, the same value of opposite signs. When we add them together, they will cancel. Negative 2 times a positive 5y gives us a negative 10y. Negative 2 times 2 is a negative 4. So now, again, we can simply just add these equations. When we do that, these cancel out to 0. Now we'll have negative 10y plus 3y is a negative 7y. Negative 3 plus negative 4, or negative 3 minus minus 3 minus 4 is minus 7. So what we have here is now negative 7y. To get that by itself, we simply just divide both sides by negative 7. And what we have is y is equal to positive 1, which is exactly what we want because that's what we found in every other equation. So now that we have y is equal to 1, all we have to do is just substitute this back into either one of our equations and solve for x. Once again, I think it's going to be easier just using this bottom equation. X minus 2 is equal to negative 5y. So now we're going to substitute y equals 1. X minus 2 is equal to negative 5 times 1. X minus 2 is equal to negative 5. Add 2 to both sides of our equation. X equals negative 3. So our answer, again, is negative 3, 1, which is exactly what we're looking for. Because now this is the same answer that we got everywhere. All right, so now let's take a look at, here we go again, another one. Let's take a look at this problem now. Here we have a set system of equation. We're going to solve it by graphing, substituting, addition, and elimination. So here we can see that this is not, this is in standard form, which is ax plus by is equal to c. Now you can either do an xy table or you can put this in slope-intercept form. I'm going to put it in slope-intercept form and I'm going to show you why. So now to do that, I'm going to write both equations because both of them need to be changed. And to find slope-intercept form, that just means we solve for y in each one of these equations. Well, to solve for y here, we're going to subtract x from both sides of my equation. We're going to have negative 2y is equal to negative x minus 2. And now we can just divide all terms by negative 2. When we do that, we get a positive y is equal to a negative divided by a negative is a positive 1/2 x. And just remember, there's implied a negative 1 out front. And then negative 2 divided by negative 2 is a positive 1. So we get y is equal to 1/2 x plus 1. So we know that our slope is just a coefficient out in front of x. It is 1/2. And our y-intercept is just going to be in the form 0 and then whatever this value is at the end, plus 1. So it's going to be positive 1. So now we're going to do the same thing for this. We're going to solve for y. To do that, we add 2x to both sides of our equation. We get 4y is equal to 2x plus 4. And now we're going to divide all terms by 4. So when we do that, 4 divided by 4 is just 1, so we're going to get y. 2 divided by 4 can be simplified to 1/2, so we're going to get 1/2 x, and then 4 divided by 4 is just positive 1. So once you know it, they are the exact same equation. There is no difference. They have the same slope. They are at the same point, which means slope 2 is also going to be 1/2, and the y-intercept is going to be 0, 1 again. In other words, it's the same line, but we still want to plot this out. So to do this, the first line, our y-intercept is 0, 1. So at 0, y will be 1. And then we have a slope of 1/2. Remember, that's rise over run. So for every 1 we move up, we'll move over 2. So at the point we have, we'll move up 1 and we'll move right 2. So here's 2 points. That's all you need for a line. So now we'll do the same thing, which will be redundant for this one. The y-intercept is at 0, 1. It's the same spot. And then the slope is the same thing. It's still rise over run. For every 1, run. For every 1 we move up, we move right 2. So we will move up 1, right 2, and we have the same point. So now what we have are 2 points for 2 lines that are exactly the same point. So when we draw this line out, I'm going to draw it for both of them. Let's see if I can do this well. There we go. Hopefully you recognize they are the same line. So again, I'm just going to go 1, and just to make it clear, we'll go 2. And here we are representing both 1 and 2. So what does this mean? This means that we have all real solutions. It does not matter where you are, the other equation is the exact same equation. So this point will correlate to the exact same point because it's the same line. So knowing that it's all real solutions, we still have to put this in the correct form. This will be very important for when you do your WebAssign homework because you're going to find problems that look exactly like this. So what you need to do is still write out what it would be in an XY coordinate. Now, how do we do that if we know they're the exact same? Because if you start messing around with this, you're going to end up with the exact same equation. You're going to have one number equal to another. Well, what you need to do is solve either one of these equations for y, which is exactly why I did it this way. So what this means is when x is x, in other words, our first coordinate is always just going to be x for all real solutions. So when x is x, y equals 1/2 x plus 1. And that's literally going to be your second coordinate. And hopefully this makes sense. This is still in the form xy. When x is x, we solve for x here. Y equals 1/2 x plus 1. So y is 1/2 x plus 1. It's just solved in terms of x. Now this is very important, again, because this is what your WebAssign homework is going to have you do. And they have good videos in there to show this. But this is the answer of how it would be graphed. Now, knowing that it's going to be all real solutions, when we solve by substitution, we expect to find a true statement, no matter what it is. So to solve by substitution, we either get this x by itself, this y by itself, that x by itself, or that y by itself. So we already see we have a coefficient of 1 in front of x. It'll be very easy to make this solvable for x. So I'm just going to write that over here. X minus 2y is equal to -2. I'm going to solve for x to do that. Add 2y to both sides of our equation. And we have that x is equal to 2y minus 2. So now we can substitute x, this is what x equals, into this equation. We're going to take this x and we're going to substitute that into our second equation. So we're going to have -2x, which is now 2y minus 2. So what we're going to do is go 2y minus 2 plus 4y is equal to 4. I'm just finishing off the rest. So now we have to distribute the negative 2 across both terms. Negative 2 times 2y is negative 4y. Negative 2 times negative 2 is positive 4. Plus 4y is equal to 4. So we have like terms. We have a negative 4y and we have a positive 4y. Well, when you add those together, those cancel out to 0. And what you have is 4 is equal to 4. There's no variables left. This is just a true statement. And when you have a true statement, what this means is it does not matter what you put in for x or y, you're going to always have a true statement. Why? Because they're the exact same line. It does not matter which point you pick on the line, it's going to be the same point on the other line. In other words, it's all real solutions. But once again, you don't just put all real solutions, you would solve it in this form. And what you would do is simply just take one of these two equations and solve for y and write it out the same way. When x is x, y is equal to 1/2 x plus 1. Sorry, that's a little messy there, but it's the same thing as it is here. It's just 1/2 x plus 1, and that would be our ordered pair. Now we can do it one last thing, We can solve by addition and elimination. Now to do this, we need the same value with opposite signs. So we already have opposite signs, we just need to get the same value. Now for x and y both, what we can do is just multiply the top equation by 2. So remember that the multiplication has to be across all three terms. So when we do that, we'll have 2 times x, which is just 2x, 2 times negative 2y, which is negative 4y, 2 times negative 2 is negative 4, and then I'm just going to put in this second equation. So we have 2x plus 4y is equal to 4. And what we want to do is simply just add the two equations together. So when we do that, 2x minus 2x is 0. Minus 4y plus 4y is 0. Negative 4 plus 4 is 0. We get a whole bunch of zeros, but just keep in mind, 0 equals 0. This is still a true statement because 0 does in fact equal 0. It does not matter what you put in for x and y, it will be on the other line as well. So here, a true statement just means it's all real solutions, and you would do the same thing. You would simply let x be x, and then solve for y. Y equals 1/2 x plus 1. So here you can see that we get the same answer, but it's solved in terms of x. It's not a number, a nice easy number like we had here. Numbers, numbers, numbers. What we have are actual answers in terms of variables. We still don't know what x is, and that should make sense because our answer will be dependent on which answer we find. So hopefully you remember from the last section that when we have the same line, this system of equations are dependent on each other. And the same thing before. In our previous one, when we found one answer, there's only one point that makes this true. That makes that an, I need to really think about that. I would think that makes that a consistent, there it is, a consistent solution because there is consistently just one point. So this is a consistent solution. If you had no solution whatsoever, that would be an inconsistent solution. And then when we have all real solutions, that means that this is a dependent solution. So just make sure you know that as well. All right, let's do one final problem, and I taped these way too well to the table. Let's take a look at a problem where we don't have easy numbers. Now, we're not going to graph, we're not going to do substitution. We are simply going to solve by addition or elimination. So what we want to do here is deal with these. So to do addition and elimination, we need the value out in front of x or y to be the same value but opposite signs. Well, here we have a mess with all these fractions. It is going to make your life very easy to just get rid of these fractions. Because we are dealing with an equation, that means there's an equal sign, that means we can actually just get rid of these denominators. To do that, we'll find the least common denominator of all three fractions for this first equation. Well, 3 goes into 6, 3 goes into 6, 6 goes into 6. Our lowest common denominator, is 6. So what we want to do then is literally multiply this entire top equation by 6 every term. And just to move faster, we can do the same thing down here. We're going to find the least common denominator. 2 goes into 6, 3 goes into 6, 6 goes into 6. Our lowest common denominator, again, is 6. It's not always going to be the case that they're the same lowest common denominator. In this case, they are. So what we're going to do is multiply all of our terms by that 6. Now, when we do that, we're going to end up with the following. Up here, we have 6 times, and I'm just going to write the whole thing out, 6 times 5x over 6 plus 6 times y divided by 3 is equal to 6 times 19 over 3. And the same thing will be for the second. I'm just going to work with this. So here we can see the 6's cancel out. Remember, every whole number is still a fraction over 1. So we have a 6 on the top, 6 on the bottom. Those cancel out. We have 5x. Now here we have a 6 on the top, a 3 on the bottom. Hopefully you realize this can reduce. 3 goes into 6 2 times. 3 goes into 3 1 time. We have 2y divided by 1, or 2y. Now this last one is the same concept. 3 goes into 6 2 times. 3 goes into 3 1 time. 2 times 19 is 38. 38 divided by 1 is still 38. So now our first equation without fractions is 5x plus 2y is equal to 38. Now let's do the same thing for the second one. Here we're going to have 6 times 2x divided by 3 minus 6 times y divided by 2 is equal to 6 times 35 over 6. So the same thing what we had on top. 3 goes into 6 2 times. 3 goes into 3 1 time. 2 times 2x is 4x. Minus, here, 2 goes into 6 3 times. 2 goes into 2 1 time. So we have 3y divided by 1, or minus 3y, is equal to, well, 6 cancels with 6. We're left with 35. So now we have two equations. These are still the same equations. I did not change the equation. All I did was get rid of the fractions. They represent the exact same thing. Now we're doing addition and elimination, which means I'm going to line the first one up over the second one. So we've got 5x plus 2y is equal to 38. Now the second equation is 4x minus 3y is equal to 35. Now in order to solve this by elimination, we need one of two things. The variable out in front of x to be the same but opposite, which means both of these numbers need to be the same, but one needs to be a negative, one needs to be a positive, or the same situation for y. We need to have the same value coefficient out in front of opposite signs. Here we can already see they're opposite signs, so I'm just going to work with that. So in order to get the same number here, you're going to look at the lowest common denominator again. Well, 2 goes into 6, 3 goes into 6, so 6 is the number we're going to want to change this to. In order to change negative 3 into a 6, we're going to multiply the second one by 2. And to turn 2y into 6, we're going to multiply this top row by 3. By doing that, we'll end up with negative 6y, and we'll end up with positive 6y, which means these will cancel, which is what we want to do. So the 3 has to be distributed across all terms, and likewise, the 2 needs to be distributed across all the terms on the second equation as well. So when we do that, 3 times 5x is 15x. 3 times 2y is just going to be a positive 6y. And now we have 3 times 38. What you will do, and what you should do, is take out a calculator and literally just go 38 times 3. It'll be much faster. You should be able to do this by hand, but as long as you're home, as long as you've got the tools, go ahead and just use the tools. So this is going to be equal to 114. And down below, it'll be 2 times 4x, which is 8x. 2 times negative 3, which is a negative 6y. Now we have the same value of opposite signs. These will cancel out. And then we have 2 times 35, just 35 doubled is 70. So now what we want to do is add both of these equations together. And when we do that, 15x plus 8x is 23x. 6y minus 6y is 0. That's exactly what we want. We want to get rid of one of the equations. And then 114 plus 70 is 184. So now we're left with 23x is equal to 184. And once again, you're probably going to want to come out and take your calculator, because to solve this, to get x by itself, we divide both sides by 23. When you do that, you got x on this side, and then you've got 184 divided by 23. Once you look at that, it's exactly 8. So what we have done here is now we know what the value of x is. It is 8. Now, to solve for y, we simply just put 8 and sub it back into one of our two equations. Now, if we did it up here, these would be very complicated. But remember, we uncomplicated both of these equations. These equations represent the exact same thing as these do as well. So instead of putting 8 into this complicated one, I'm going to put 8 into a less complicated one. And it does not matter which one you use. You will end up with the same value. So what I'm going to do is I think I'm going to put it into just the first one, just to stay consistent. So our first equation is 5x plus 2y is equal to 38. Now we found x to be 8, which means we're going to substitute x in for x in this equation. So we're going to have 5 times 8 plus 2y is equal to 38. 5 times 8 is 40, plus 2y is equal to 38. To get y by itself, we subtract 40 from both sides of our equation. We're going to end up with 2y is equal to negative 2. And then to get y by itself, we simply divide by 2. Y is equal to negative 1. So now we have a point, 8, negative 1, as an answer. But it is always a good idea to check your work. Well, to check your work, all you have to do is substitute x equals 8 and y equals negative 1 into any one of our equations. So since I used the first equation, you could literally put this right back in and get the same answer. I'm going to check it using the second equation. So the second equation says we have 4x minus 3y is equal to 35. So all we have to do now is just put x equals 8, so 4 times 8 minus 3, and y is now negative 1. Make sure you use your parentheses, it's going to help, is equal to 35. Well, 4 times 8 is 32. Negative 3 times a negative 1 is a positive 3. So what we have is 35 equals to 35. This is a true statement, which means our answer must be correct. So here is an example where you want to clear out your denominators if you can. Literally get rid of the fractions. We can do this because there is an equal sign. If there was not an equal sign, then you would have to multiply by some version of 1, and you'd have to get a common denominator. Here, we're looking for the lowest common denominator. We multiplied all terms by that, and that way it cancels out so we don't have any fractions. So this is something you definitely will be seeing on your homework. All right, so the last thing I want to touch on now is quiz number 6. Here is the point in the semester where we're really going to have to work and put effort into making this part of it work. You're still going to have to turn in quizzes. You are still going to have to turn exams in, and that's how you're going to have to do this, is you're going to literally have to keep doing it by taking pictures and emailing it to me. Or if the pictures don't work, find any method you can to send me the picture or the work and the answers you have. I need to visually see it one way or another. Now, there's a lot of ways to do this. You can literally just take a picture on your phone and email it that way. The only problem is if you have a nicer phone or any other phones that take high quality pictures, if we have an exam that's 10 pages long and you try and send 10 pictures, you may end up with super large file sizes, And depending on how much you can actually send, you may not be able to send that file size. So in here is a list of all kinds of steps. This will also be listed on Blackboard, so you don't have to just stop the video and look at it here. This will already be somewhere else. But the point of this is literally, how are you going to get your work and answers to me? So this is what this quiz is all about. I'm not too worried about the answers you got, because the problems I'm using is literally straight out of the videos from Jim that you should be watching. But the idea is, how are you visually going to show that to me? So from here is a good place to stop. It's just extra work at this point. Make sure you do the WebAssign homework. Make sure you ask any questions you have, and make sure you know how to send me your work and your answers. All right, that's it from me. Thank you for listening.